morning to you all. Today we are going to discuss the UPSC Maths Optional Paper 1 Section 8. In that, linear algebra questions. Okay, right. And calculus questions also. What they have asked in the 2023 Mains Maths Optional Paper 1 Section 8. And along with analytical geometry. Three things we are discussing on this video. First one is what? Linear algebra. And second one, calculus. Third one is analytical geometry. How the paper is and what kind of questions they have asked. Each and everything I am going to discuss right now. Okay? Right. And first question, see. First question they have given, let V1 or maybe V2 or V3 are three vectors of the vector space. Space nothing but a vector space R power 4. R power 4 nothing but what? V4 of R only. 4 tuples. Vn of R, n tuples. R power n tuples. Therefore, V power of R is what? 4 tuples. Maybe alpha, beta, gamma, or alpha 1, alpha 2, alpha 3, anything. Okay, right. Does this vector 3 minus 1, 0, 1 span V1, V2, V3? And justify your answer for 10 marks. Right. Now, you can take like what they have given to you, V1, V2, V3, right? Okay. Right. What they have given? Let V1 is equal to let V1 is equal to, what is this vector? 2 minus 1, 3, comma 2. And V2 is the vector is what? 1, 1, 1, triple 1, minus 1, sorry, 3, comma. And V3 is equal to what? Double 1, 1, 1, and 9, minus 5. Right. Are the three vectors of the space R power 4? R power 4. Or I can say, what is this R power 4 means? R power 4, V4 of R. R power 4, nothing but what? R power 4 is equal to what? V4 of R only. 4 tuples. 4 tuples. 4 tuples. Does the vector, what is this vector? 3 minus 1, 0 minus 1 is spanning these vectors V1, V2, V3. Right. Now, we know that if any vector, if it is a spanning, nothing but L of S. Linear span is nothing but what? Linear combination. What is that span? Nothing but linear combination of the vectors. Right. Here, let it be this vector is V4. If V4, if it is spanning V1, V2, V3, I can write it as what? There exists a scalars. V4 is equal to, I can write X into V1. There exists a scalars. And Y into V2 plus Z into V3. If there exists a scalar X, Y, Z are what? Belongs to the field elements. What is this field here? Real number. If there exists scalars X, Y, Z in a such a way, V4 is equal to X into V1 plus Y into V2 plus Z into V3, then we can say that what? V4 is spanning the V1, V2, V3. Otherwise, it is not spanning. If you are able to find the scalars X, Y, Z, nothing but real numbers. If you are able to find, I don't know whether we can able to find or not. Okay, if we are able to find, then definitely it is a spanning, otherwise it is not. Okay, right. Therefore, I have written the same thing. Therefore, let it be 3 minus 1, 0 minus 1 is equal to what? X into V1. 2 minus 1, 3, 2 plus Y into V2 minus 1, 1, 1, 3 plus Z into V3 1, 1, 1, 9 minus 1. Okay, this implies 3 minus 1, 0, 1 minus 1 is equal to what? I can say 2x minus y plus z. Next, minus x plus y plus 9z. Next, what? 3x plus y plus 9z. Okay, I have done the wrong. This is what? Minus x plus y plus z. It is not a 9z. Okay, plus z. Plus y plus z. Next, third coordinate 3x plus y plus 9z, and whatever the fourth coordinate is equal to what? 2x plus 3y minus 5z. Therefore, this is also 4 tuple. This is also 4 tuple. The corresponding coordinates must be the same. Therefore, what is the first equation? 2x minus y plus z is equal to 3. And what is the second equation? Minus x plus y plus z is equal to minus 1. Next, what about the third equation? 3x plus y plus 9z is equal to 0. What about the fourth equation? 2x plus 3y minus 5z is equals to what? Minus 1. These are the 4 linear equations. Again, I am confirming. These are how many? 4 linear equations we have written. Okay, right. 2x minus y plus z is equal to 3. Minus x plus y plus z is equal to minus 1. 3x plus y plus 9z is equal to 0. And 2x minus 3y. See, somewhere we have committed the mistake, right? 2x minus 3y. I think third vector v1, v2, v3. 2x minus 3y minus 5z. 2x minus 3y. 2x plus 3y minus 5z. I think this vector is minus 3. I have done small mistake. Okay, let me correct. Okay, this vector is, I have written the wrong. Minus 1, 1, minus 3. Doesn't matter. Okay, but I don't know what they have given. We should not change the question. Okay, right. Minus 1, 1, minus 3. Therefore, what about here? Here is also minus 3. Therefore, what about here? Here is also minus 3. Right. 2x minus 3y minus 5z is equal to minus 1. Right. Right. Now, you can use that what? These are equations are what? Non-homogeneous system of linear equations or homogeneous system of linear equations? These are non-homogeneous system of linear equations. Now you can able to find the A augmented matrix Ax is equal to B. Okay, right. Anna? Why? Because we have to find the x, y, z. If any three are using the calculator, either this equation 1 or equation 2, you can take any three equations. 1, 2, 3, 4. You can take the any three equations. You have a 4 choices. Either 1, 2, 3 you can take any, that is up to you. Either 1, 2, 3 you can take, or maybe you can take 1, 2, 4, or maybe you can take 1, 3, 4, or maybe you can take 1, 2, 3. 1, 2, 3 already you have taken. This is 1, 2, 4 and 1, 2, 4 and maybe 2, 3, 4. Any of the equations you can take. And you can able to find the x, y, z. After that, after finding the x, y, z, the rest of x, y, z equations, if it is satisfying, that x, y, z values, if it's satisfying remaining equation. Here, what is the missing equation for? If remaining equation, then we can say that we have found the scalars x, y, z. Otherwise, we haven't found. That doesn't exist. We can write. Are you understanding? Here is also, you can take the 1, 2, 4 equation. You can able to find x is equal to something and y is equal to something and z is equal to something. If this x, y, z values, if it is satisfying the equation 3, then definitely we have found scalars x, y, z. Otherwise, not. Are you understanding? The same thing here and here. This is the one procedure. Using the calculator, you can able to find or not. That is hardly for you. It is a 2-3 minutes only. Okay. Otherwise, you can also find by what? System of linear equations. No. You can write the augmented matrix AB. And this is Ax is equal to B. You can use this technique also. Not a problem. Ax is equal to B. Right? I am using that one only. Therefore, you can choose any 3 equations. Suppose if I am choosing the 1, 2, 3. If I am choosing the 1, 2, 3, or maybe you can, if you want, you can choose the 1, 2, 3, 4 also. Doesn't matter here. Okay, right. I am choosing the 1, 2, 3. So Ax is equal to B. Therefore, 2 minus 1, 1, 3. Okay, right. Minus 1, 1, 1, minus 1, and 3, 1, 9, 0. Okay, right. If you want, you can choose this equation also. Otherwise, not required. Okay. That is up to you, beta. Right. I know that A, X is equal to what? X, Y, Z is equal to B. This is the B matrix. If I want, I can choose this equation also. If you want, you can write. Okay, 2 minus 3 minus 5 minus 1 also. Doesn't matter. Okay. What is my intention? I have to find the XYZ linear equation. Can I able to find or not? I can able to understand from here only. Okay. Therefore, I am using the row operations. Now you can choose simply, you can transfer the row R1 to R2. You can transfer. Then above matrix will be equal to what? Minus 1, 1, 1, minus 1. Next 2, minus 1, 1, 3. Next what? 3, 1, 9, 0. 3, 1, 9, 0. 3, 1, 9. Now, what are the operations? How to make the 0 here? Therefore, you have to use what? R2 plus 2 times of R1 and R3 plus 3 times of R1. Then the above matrix equal to what? First row is as it is, 1 minus 1, 1, 1, minus 1. Okay. What about the second row? 0. And what about here? You are multiplying the 2, you are adding. 2 1 are 2 minus 1, 1. And 2 1 are 2, you are adding 3. And minus 2 plus 3. How much? Minus 2 plus 3. Nothing but 1. Next, if you can multiply with 3 on row 1 and you can add. Therefore, 0. 3 1 are 3 plus 1, 4. 3 1 are 3 plus 9, 12. Minus 3. That's it. And using this one, you can make the 0 here. Therefore, R3 minus 4 times of R2. Then this matrix minus 1, 1, 1, minus 1. Next 0, 1, 3, 1. Next 0, 0. Okay, 4 3 are 12. This is also 0. And this is also 0, right? 4 3 are 12, 12 minus 4 1 are 4, minus 7. Minus 7. Therefore, what are the equations right now? What are the equations right now? Okay, I am writing here. Okay, I am writing here. Here, a minus x plus y plus z is equal to minus 1. Next, y plus 3z is equal to what? 1. And here, 0 is equal to what? 0 into x is equal to minus 7. This is the what? Inconsistent. Inconsistent. Or rank of A is 2 and which is less than rank of augmented matrix is 3. 2 less than 3, which is the inconsistent. You cannot able to find the scalars. Okay, there doesn't exist x, y, z. There does not exist x, comma, y, comma, z belongs to real numbers. Okay, system of linear equations are inconsistent. That is the main probe. Okay, are you understanding? Clear? Right. Some people can write the here fourth equation also. If they want, you can write. It doesn't matter. If you want, you can use this one also. Again, you have to do the few more operations. Are you understanding what is my idea? Okay, right. Therefore, at last you have to write what? At last you have to write V4 is not spanning the vectors are what? V1, V2, V3. Why? What is the reason? We cannot able to find the real numbers x, y, z. That's it. This is the first question for you. Next. What about your second question? Find the rank and nullity of the linear transformation. Rank and nullity. What is the rank? Rank. What is the rank and what is the nullity? And before that, you have to know that what is the linear transformation. In that, what is the null space and what is the range space. And the dimension of null space, we are saying that what? Nullity. Denoted by what? The Greek symbol mu. And the dimension of the range space, we are calling as what? Rank. We are denoting as a row of T, nothing but row T. Are you understanding? and right. Find the rank and nullity of the linear transformation. Do you know that? Just now I have explained what is the null space and what is the nullity, and what is the range space and what is the rank. Okay. Next, they have given 3 tuples to 3 tuples, r cube to r cube they have given, and given by some transformation they have given t of x, y, z. How they are mapping? X plus z, x plus y plus 2z plus 2x plus y plus 3z. This is the mapping transformation they have given. They are not asking to show the transformation. No, that is not the question. Therefore, no need to show the linear transformation. Why? Because it is a wastage of your time and answer sheet space also. Okay, na? People are unnecessarily doing, sir, I have to show that here. Why? Because in the textbook or in our material, first I have given this question is what? Show that T is a linear transformation and hence find the rank and nullity. This is the direct question from our study material. Okay, but that study material what we have asked it just to show that linear transformation first, and after that I am emphasizing the find the rank and nullity and the range and null space. All these 4 5 things. Okay, but here question 10 marks. They have asked only the nullity and rank. That's it. Nothing else. Okay, just now we are focusing on there only. Right. And before going to and explaining, even straightforward question, even one just previously we have discussed this question. This is the straightforward question, basic question. You can understand. And without this question, there is no, I can say, linear algebra study material in India. I can say. Each and every study material can contain the linear algebra spanning, linearly independent, show that linearly dependent, find the basis, find the dimension. These are the major, I can say, surface questions. Even second question is also same. I know. There is no single book in an entire world. And there is no single book in an entire world without mentioning these 2 questions. Any book, if it is a linear algebra, you can pick up, or any institute, even if you are picking up the study material, these are the 2 questions will be there. Therefore, this is not nothing but paper was what? Very, very easy. UPSC Maths Optional Paper 2023 is very, very easy, especially in the linear algebra. I tell you what are the questions others are lacking and what are the questions we have only. I tell you, don't worry. Okay, right. Come to that. Here they have given the transformation. What is the transformation? T of x, y, z is equal to what? They have mentioned x plus z, comma, x plus y plus 2z, x plus y plus 2z, comma, 2x plus y plus 3z, 2x plus y plus 3z, 2x plus y plus 3z. Okay, they have given. They're asking the only null space and rank. Do you know that? What is the null space? How many vectors? Let it be. This is the U is the vector space and V of F is the vector space, are 2 vector space over the same field. These are the 2 vector space over the same field. And T is a one linear transformation. T is a linear transformation. From here to here, you can able to travel from the one vector space to other vector space. Why? Because of you have a linearity and you can transform. Okay, you have nothing but from these vectors you can convert it into in this. Okay, right. And what is the null space? Now, how many vectors which are mapping? Always you tell me, here the 0 vector is 0, I am denoting. Here the 0 vector is 0 dash. Therefore, T is a linear transformation. You have to map the 0 and 0 vectors. Okay, that is there. That is already you have to, otherwise it cannot be the linear transformation. Nothing but homomorphism. Homomorphism or linear transformation. It never 0 vector, you have to map the 0. Therefore, what are all the vectors which are leading to the 0 vector on this kind of set we are calling as a null space is denoted by n of t. N of t, what kind of vector will be there? Alpha such that t of alpha is equal to what? 0 dash. T of alpha is equal to 0 dash. How many vectors on this set which are mapping to the what? 0 vector on the codomain. 0 vector on the codomain. That is you can understand. And if it is a FDVS, this is the FDVS, then null space, one more thing, null space always what? Subspace. Null space is what? Subspace. And if it is a FDVS, then null space is also what? FDVS only. FDVS means what? Finite dimensional vector space. Finite dimensional vector space. If null space is the finite dimension, you can able to find the dimension. That dimension of null space only, what we are calling? Dimension of n of t. Dimension of only we are calling as a nu of t. We are calling as a nu of t. This is only we are saying that nullity. That's it, nothing else. Nullity. And how many vectors are mapping? Suppose in this zone there is no pre-images. Let it be. Here there is a beta. There is no alpha. Nothing but in this zone there is no. These are all we have the pre-images. Such kind of vector space is what? R of t. Range space. Or sometimes we can call it as a range. Anything. Range space. Why we are calling it a range space? Because of this is also what? Subspace. When I don't want to V of F is a FDVS or not. I don't want to on the codomain, but I need, if it is a FDVS, U of F is a FDVS, definitely R of T is also FDVS. Range space, what is the range space vector? How many vectors? Beta such that T of alpha is equal to beta, that's it. If there exist the pre-images in that U for some alpha, here if you want you can write for some alpha belongs to what? Domain. Alpha belongs to U. Such kind of vectors will be in the, such kind of betas will be in the R of T. Therefore, if U is a FDVS, then R of T is also what? Subspace. That subspace is also what? Finite dimensional vector space. That you can understand. Okay, finite. And that dimension of R of T only, we are denoting as rho of T. That is only we are calling as a rank. rank. That's okay, right. In this question, come to that our question. Both are, they have given that what? FDVS to FDVS. That is okay. R cube to R cube, they have given transformation, they have given, and they have given the transformation. Then one vector, 3 tuple, it is also mapping to the what? 3 tuple. They have mentioned the transformation. Therefore, again, I am giving the some note point. Don't show that linear transformation here. Why? Because of already they have mentioned the transformation. Therefore, no need to show that linear transformation. What is the problem? Even if you are showing the linear transformation here, the problem is what? You are wasting your time. Main examination time you are wasting, and you won't get any marks from that. Okay, main you have to find the rank and nullity. That's it. Then only they will give the 5 marks for nullity and 5 marks for rank. Okay, right. Okay, come to that. Now I told you already. Therefore, if I am taking the alpha, let alpha is equal to what? X, Y, Z. Then automatically you tell me T of alpha is equal to what? 0 dash. Here 0 dash is what? Here is also same. 3 tuples. What is the 0 vector? 0 and 0 dash are both are same only. 0 dash is equal to 0 is equal to what? 0, 0, 0. 3 tuples. 0 vector. Okay. Therefore 0 vector. R cube. Okay. Right. T of alpha. T of X comma Y comma Z is equal to 0, 0, 0, 0. What is the formula for? They have given the transformation. X plus Z comma X plus Y plus 2Z comma 2X plus Y plus 3Z. That is equal to what? 0, 0, 0, 0, 0, 0. And therefore, what are the equations? X plus Z is equal to 0. X plus Y plus 2Z is equal to 0. And 2X plus Y plus 3Z is equal to 0. Okay, right. Now, I am taking the first 2 equations. You tell me here what? X plus Z is equal to 0. Then X, what about the here? X plus Z is equal to 0. Can I write it as X plus Y plus Z plus Z is equal to 0. I have written just like this equation. X plus Y plus Z plus Z. X plus Z already 0. You can remove. Therefore, Y plus Z is equal to what? 0. X plus Z is equal to 0. Y plus Z is equal to 0. Therefore, Y is equal to minus Z. Minus Z, and X is also from here what? X is also minus Z. You can able to put all these values. Therefore, 2 minus 2Z minus Z plus 3Z is equal to what? 0. Nothing but it is a matching. 0 is equal to 0. Right? Therefore, what is I can write? Let x is equal to minus z. Are you understanding? Therefore, what about the vector? Alpha is equal to x, y, z. For understanding, let z is equal to k. Even if you're not writing also, doesn't matter. Okay. For sake of convenience, z is equal to k. Z is equal to k. What about the x? You tell me. X is equal to what? Minus k. Y is equal to what? Minus k. And z is equal to what? K. Therefore, this is equal to what? I can say minus k, and k. That is equal to what? Minus k times of 1, 1, minus 1. Or k times of minus 1, minus 1, 1. Therefore, what kind of vectors will be the null space? N of t. All these form of these vectors. And null space, all these forma of these vectors will be the null space. Therefore, what is the basis? Basis vectors are what? Minus k times of, I can say 1 comma 1 comma minus 1 will be the what? Basis. Will be the basis. Only the one vector it is forming the basis, and it is FDVS. Therefore, what is the dimension of here? Dimension of n of t is equal to 1 only. Dimension of n of t is equal to what? 1. Okay, don't think such a null space will contain the only one vector. No, that is not the meaning. That is not the meaning. Null space contains a lot of vectors, infinitely many vectors. In fact, infinitely many vectors. All these vectors in which are format what? I can say minus nothing but 1, 1, minus 1 into some constant k not equal to 0 here. K 0. What will happen? 0, 0, 0. That is also will be the null space. Without 0 vector, they can't be the null space. Therefore, k belongs to what? Here, 0 and non-zero both. Therefore, k belongs to what? Real number. Infinitely many vectors of this kind will be the null space. Okay, if you want, you can write. If you have some confusion, null space contain alpha such that alpha is equal to what format? Minus k, k, or k minus k. Anything you can write, doesn't matter. And where k is equal to what? Where k is equal to belongs to a real number, maybe 0 or non-zero, anything here. Okay, therefore, what is the basis? What is the basis for null space? Basis vector s is equal to what? Minus 1, 1, 1. This vector in the only the one vector in the basis. Minus 1, 1, or anything you can write. That is up to you, beta. 1, 1, minus 1. Anything you can write. There is no problem for you. Okay, therefore, what is the dimension of n of t? What is the dimension of n of t is equal to what? Only 1. Now, next. Sir, can I have to find that? Are they asking to find the range space? No, they are not asking. Only they are asking the rank. Therefore, we can use the rank nullity and nullity theorem. Therefore, if it is FDVS, dimension u is equal to what? Dimension u is equal to what? Nullity plus rank. I can say nu of t plus rho of t. That is the dimension u. Therefore, according to the question, what is the dimension u? R cube dimension is what? R cube is FDVS of dimension what? 3. Therefore, 3 is equal to what? 1 plus rho of t. Therefore, what about the rho of t? Rho of t is equal to how much? 3 minus 1 is equal to 2. That's it. That's it. Very simple. Hardly you can able to execute within 3.5 minutes for this question. 3 and hardly I can say 2 to 3 minutes. Nothing else. I haven't done much. See. Even 3 minutes also more than. Just with explanation, I am taking this much time. I am explaining. Maybe you don't know. Maybe freshers. You don't know what is the null space. You don't know what is the range space. You don't know what is the linear transformation. Each and everything. Okay. For writing, if you know the content and already how to solve, how much it will take? I don't think so. Not more than 3.5 minutes, or maybe make it as 4 minutes. Even if you are writing the slow. Okay, these questions are what beta standard questions only. Each and every material will contain these kind of questions. Therefore, there is no crazy about any materials. Okay, I tell you what is the difference, what is the unique point, unique selling point, and a unique point, USP in our and rest of that. I will tell you what kind of questions we have, and no one have in all over India. This is our challenge. And you. They don't have any What kind of question? They don't have any answers. I will discuss on the journey. Okay, these are the two linear algebra questions. Very, very dead easy questions only. Every maths option student, I hope so, they can able to present. However, the pressure in the inside the examination hall. Okay, these are the standard questions. Now, I am moving for the one more question. Okay, right. Next, these are the first 1A and 1B bit. Next. Only I am teaching right now, I am focusing on right now only linear algebra and matrices only. Okay, I am focusing on only linear algebra and matrices. Okay, I will take after that, few completion of the my linear algebra and matrices. We are going to discuss calculus and analytical geometry. Okay, don't worry. Right, 1A and 1B. 1C you can hold calculus and 1D also calculus. This is the analytical geometry. Come to the 2A question. Again, if the MLT means what? Matrix linear transformation. If the MLT, matrix linear transformation, defined by what? R cube to R cube, relative to the some basis, is this much they have given. Nothing but they haven't given the any formula. They haven't given the any transformation. Just they have mentioned that, some basis. This is the output, T of B. Matrix linear transformation with respect to the one ordered basis. They have given that what? T of B. Are you understanding? Right, they have given this much. Then find matrix of T. Nothing but they are asking MLT. This question is what? Indirect. Okay, they are asking what is the formula for MLT? How we are transforming of this vector. This is the basis vector to this matrix. What is the formula? What is the transformation? That is only they are asking. That is the first thing. And what about the second thing? And again, then find the matrix of T relative to the basis. Therefore, using the transformation, then what is the MLT of this basis? This is the non-standard basis. And this is the standard basis. They are asking to find how many marks? 15 marks. Yes, what full question on? Okay, we can able to solve it, right? Okay, right. Come to that. And now I am writing what is the MLT they have given? Matrix linear transformation. MLT T R cube to R cube they have defined. R cube defined. What is that ordered basis? Standard ordered basis. They have given 100 and 010 and 001. What is that 001? What is the standard basis of B or S? Whatever you can call it as, it doesn't matter. Okay, T of B they have given. Okay, we have to write the column wise only. Okay, first column is what? 1 minus 10. Okay, minus 10. Second one is what? 1 to 1. 1 to 1. What about the third column? 2, 1, 3. Okay, we are able to find we have to find the scalars and we have to write on the column wise. Okay, right. Next, then find the matrix of T relative to, later I will come to this second part. They're asking that then find the matrix of T relative. First, we have to find the transformations. And therefore, I have taken that what? This is the R cube. Domain is also R cube and codomain is also what? R cube. Both are FD based only. And this vector, I don't know what is the transformation, but this is the basis. They have given this set of these vectors alpha 1, alpha 2, alpha 3 are what? Basis for here, alpha 2, alpha 3 are, we know that. What kind of basis? Standard basis. Standard basis. V2 of our standard basis 1001. V3 of standard basis, this one 100, 010, 001. I says blah blah blah. Vn of R power n. What is the standard basis? 1, n minus 1 times 0 and 01, rest of the zeros and 001 and rest of all zeros. Last vector alpha n I can say 00 blah 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 n minus 1 zeros and last vector is the 1. These are the standard basis, right? Now I have taken the here one vector I am taking xyz. Let alpha is the xyz. The vector will be the what? Domain. Let alpha is equal to what? Xyz. Any vector you can take. Belongs to what? I have taken the R cube. I have taken domain. Therefore, this is the standard basis. Therefore, every vector outside of the vector in the vector space, nothing but outside of the standard base. Every vector I can able to write what? Linear span. Why? Because a base is nothing but what? Linearly independent and spanning. Therefore, this is the basis. S is the basis. Therefore, every vector outside of that basis, even inside also, nothing better. Every vector in the vector space, I can able to write what? A linear span or linearly independent. Therefore, I am writing the what? Let alpha is equal to what? Linear combination. I can write, okay, x, y, z is equal to what? I can say x, y, z is equal to, directly I can write here. Okay, right, x, y, z is equal to, I can write what? X into 1, 0, 0. Why? Because of standard basis, right? Are you understanding? This is alpha 1, alpha 2, alpha 3. Alpha is equal to what? X into, if you want, you can write in this way. Alpha is equal to x into alpha 1 plus y into alpha 2 plus z into alpha 3. Therefore, alpha is equal to, okay, this is the alpha 1, alpha 1, alpha 2, alpha 3. Okay. Now, what is the transformation here? T of alpha is equal to x into T of alpha 1, T of alpha 1 plus y into T of alpha 2 plus z into what? T of alpha 3. T of alpha 3. Therefore, T of alpha is equal to nothing but T of x, y, z is equal to x into T of alpha 1. What is the mapping? They have given 1 minus 1, 0. Why? Because of here, x, y, z. You have to take the column wise, right? This is the 1, this is the minus 1, this is the 0. Otherwise, if you want, you can write the formula T of alpha 1, T of alpha 1, T of 1, 0, 0. Okay, right. Can I write here in this place? Can I use T of alpha 1 is equal to what? Column wise, you have to write, right? 1 minus 1, 0. And T of alpha 2 is equal to how much? 1 to 1. And what about the T of alpha 3? 2, 1, 3. 2, 1, 3. Therefore, you can write x into T of alpha 1, 1 minus 1, 0 plus y into T of alpha 2, 1 to 1 plus z into T of alpha 3 is what? 2, 1, 3. Right? Right. Therefore, this is equal to x plus y plus 2z minus x plus 2y plus z and comma y plus 3z. This is equal to what? T of x, y, z. Therefore, we have found the what? Transformation we have found. T of x, y, z is equal to what? X plus y plus 2z and minus x plus 2y plus z and y plus 3z. That's it. Okay? Right. Transformation, we got it. And after that, we have to find the what? We have to find what? Second part. Second part, what they have given? Find the matrix of T relative to the basis. T1, 1, 1, 0, 1, 0, 0, 0, 1. Anna? Right. Here B dash, one more. Maybe make it as B dash or B, whatever. Here one more basis they have given. B dash is equal to what they have given? 1, 1, 1. Anna? Let it be alpha 3 or maybe beta 1. Anything you can write. And here is what? Second vector 0, 1, 1. 0, 1, 1. Beta 2, let it be this vector. And 0, 0, 1. Let it be this vector is beta 3. Now, you tell me T of beta 1. T of beta 1. Where it is mapping? T of beta 1. T of 1, 1, 1. Therefore, first what about the vector? 1 plus 1 plus 2, 4. And minus 1 plus 1, 2. And what about y plus 3z? 4. 4 to 4. Okay. Minus 1 plus 2, 4. 4 to 4. Right? Next, what about the T of beta 2? T of beta 2. Transformation of 0, 0, 1. T of 0, 1, 1. That is equal to x is 0. 3. Next, 3 again 4. And what about the T of beta 3? T of 0, 0, 1. Z is equal to 1. Nothing but 2, 1, 3. These are the matrices. Now we have to express what? Transformation, MLT. Therefore, again, you have to find the word standard basis you have to mention here. I know you have to mention 4 into 4 times of, you have to write what? Some scalars. Maybe you can use the scalars what? X1 into beta 1. Beta. X2 into, are you understanding? Beta 2 plus X3 into beta 3. And again, here is also Y1 into beta 1 again. Now you have to write what? In the column wise only. Here is also Y1 into beta 1 plus Y2 into beta 2 plus Y3 into beta 3 have to write. Here is also Z1 into beta 1 plus Z2 into beta 2 plus Z3 into what? Beta 3. Then the transformation must be equal to what? Column wise. X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3. we have to write. But if you're proceeding like that, it will take the time. Therefore, we can be able to derive one formula. Therefore, we can be able to, why? Because you are doing the what? More calculations. Here you are finding the three scalars, x1, x2, x3. Again, you are finding the three more scalars. Again, you have to find the three more scalars. Okay, by using the calculator, you can able to find, but why should waste that much time? Therefore, what is my advice for you? You can simply you can derive the some formula. Okay, how I am deriving, you can focus on that. Okay, now, okay, I am not going in this way directly. I am taking the word. It will take the time unnecessarily. Okay, right. Now I have taken the word. Let x, y, z is equal to what? Let x, y, z. I am deriving the formula a into what? 1, 1, 1, 1, 1, 1, 1 plus b into 1, 1, 0 plus c into 0, 0, 1. Therefore, transformation of x, y, z. Nothing but x, y, z is equal to what? First, a plus b. Next, a plus b. Okay, this is also next. A plus c. That's it. A plus b, a plus b. I have done some small mistake. This is the 0, 1, 1. Okay, right. Do think. This is the 0, 1, 1. 0, 1, 1. 0, 0, 1. Okay, therefore, first one is what? First one is equal to a. That's it on a and a plus b and a plus b plus c. Okay, right. Therefore, right now, you can equate a is equal to x. Next, a plus b is equal to y. Y. What about the b? B is equal to y minus a. Nothing but what? Y minus x. What about here? A plus b plus c is equal to z. What about the c here? C is equal to z minus a minus b. Z minus a means minus x minus b minus b plus x. That is equal to z minus y. Therefore, I got the scalars x, y, z and a, b, c. Therefore, I can write what is the easy method. Therefore, x, y, z is equal to what about the a x into 1, 1, 1. What about the b? Y minus x into what? 0, 1, 1, 1 plus c z minus y into what? 0, 0, 1, 1. I can write. Okay, now you can express t of 1, 1, 1. T of 1, 1, 1. Transformation of 1, 1, 1. T of 1, 1. X is equal to y is equal to z is equal to 1. What is this value? X is equal to 1. Y is equal to x. Y minus x is equal to 0. Z minus y is also 0. Therefore, what it will come? X into x. X into this is what? 1, 1, 1. 1, 1, 1 plus y minus x. Y minus x, what is the value? T of 1, 1, 1. Y minus x is equal to 0. No, 0 into something 0. 0 into something 0. Therefore, x into 1, 1, 1. What is the formula for t of 1, 1, 1? T of 1, 1, 1. What is the transformation? X plus y plus z, right? You can use that formula. Okay. Otherwise, can we go y minus x, right? Z is equal to z minus y. T of 1, 1, 1. What is the T of 1, 1? Transformation of 1, 1 is how much better? Right. See, T of 1, 1, 1 is equal to what? 4. What about here? 2. What about here? 4. 4 to 4. And again, you can compute T of what is the second vector? 0, 1, 1, right? 0, 1, 1. Okay, right. T of 0, 1, 1. 1 is how much? 0, 1, 1. X is equal to 0, y is equal to 1. Therefore, 3. Okay, 3, 3, 4. Like y is equal to 1, z is equal to 1. And what about the T of 0, 0, 1? X is equal to 0, y is equal to 0, z is equal to 1. 2, 1, 3. 2, 1, 3. 2, 1. Therefore, I can write it as what? This is equal to 4 into directly. And I can write it as a T of 1, 1, 1 is equal to what? 4, 2, 4. That is equal to what? 4 times of 1, 1, 1, 1, 1, 1. I can say T of alpha. I know 4 times of 1, 1, 1 plus how much? That's it only. 4 times of 1, 1, 1 only. T of 1, 1, 1, right? 4 to 4. Therefore, 4 to 4 is equal to. Okay, let me write. Come to that. Therefore, T of 1, 1, 1. T of 1, 1, 1 is equal to what? 4 to 4. 4 to 4. Therefore, x is equal to what? 4. 4 into 1, 1, 1. If you're every time you're writing, right, let it be beta 1, beta 2, beta 2. Therefore, 4 into beta 1. And I am giving the beta 1 here. You can give the beta 2. You can give the beta 3. Okay. 4 into beta 1. What about the y minus x? Y minus x. 2 into y minus x. Minus 2 into, I can say. Minus 2 into beta 2 plus z minus y. Z minus y. 2 into beta 3. Same way. T of 0, 1, 1 transformation. That is equal to what? 3, 3, 4. 3, 3, 4. I can write it as what? X into 3 into beta 1 plus y minus x into y minus x. 0 into beta 2 plus z minus y. 1 into beta 3. Last one. T of 0, 0, 1 is equal to what is mapping? 2, 1, 3. 2, 1, 3. Again, 2 into beta 1, x into beta 1. Next, y minus x. Y minus x. Minus 1 into beta 2 plus z minus y. Z minus y. 1 into beta. Therefore, transformation of beta 1, b1 is equal to what? You can write the column wise. And 4, 4, 3, 2, 4, 3, 2. No, row wise you have to write, right? Column row wise or row column wise, anything. 4 minus 2, 2. Next 3, 0, 1. Next 2 minus 1, 1. This is the matrix linear transformation with respect to what? B dash. What we have done here? Simply we have found the one formula. Simply we have found the what? One formula. Transformation of x, y, z we have found. After that, every vector, what we are writing? Just like instead of writing the, I told you already, instead of finding the all 9 scalars, you can derive the one formula. For that formula, I have taken what? T of x, y, z. This formula x, y, z is equal to what? A into, this is beta 1 plus b into beta 2 plus c into. Then you got some values. Therefore, I have found the what? A, B, C scalars in terms of what? X, Y, Z. I found the ABC scalars in terms of x, y, z. Every time you are applying the transformation here, it will take the too much. Why? Because the total 9 equations will come. 3, 3, 3 equations, 9 scalars we have to find. Instead of that, what we are doing, x, y, z, a into alpha beta 1 plus b into beta 2 plus c into beta 3. Then I found that a, b, c scalars. Then I have written x, y, z is equal to what? A is equal to x into beta 1 plus b into beta 2 plus c into beta 3. Are you understanding now? Are you understanding? If you want, you can write it as a into beta 1 plus b into beta 2 plus c into beta 3. That's it. Here we have found the scalar c value, and here b value. B is equal to what? Y minus x. Here a is equal to what? X. Okay, a is equal to x. Then I have substituted either this equation. You can substitute a into beta 1. If you want, you can write the beta 1, beta 2, beta 2. Okay. Right, a into beta 1 if you want, x into beta 1 plus y minus x into what? Beta 2 plus z minus y into what? Beta 3 you can write. Then you can derive the formula T of 1, 1, 1 already we have found the formula. Therefore 4 to 4 is equal to what? 4x into y minus x into this. After that, entire row column wise you can write, or entire column you can write the row wise. Then you will get the what? MLT, matrix transformation with respect to what? Basis B1. This is the easiest question one. Right. Next, I will tell you the source of this question also, which page number. I will give them on this. Okay, don't worry. Next question I am going to discuss. This question is over 2A. Right. Next question. This one 3A. What they have given? Let A, they have given the one matrix and verify the Cayley-Hamilton theorem for the matrix A and show that A power n is equal to A power n minus 2 plus A square minus I for n greater than or equal to 3, where I is the identity matrix of order 3, and hence find A power 14. Okay, this is the question. Okay, they have given. See how to solve. This question also very dead easy. Okay, right. I have written as what? A is equal to one matrix. So what is that matrix? 1 0 0 1 0 0 1 0 1 and 0 1 0 0 1 0. And verify the Cayley-Hamilton theorem. Okay, right. For that what? You have to write the what? Cubic equation. A minus lambda is equal to 0. What is the characteristic equation of A? CH, characteristic equation of A is what? Determinant of A minus lambda is equal to 0. A minus lambda is equal to 0. Right? Therefore, I have to write that one. Therefore, this is equal to 1 minus lambda, determinant of 1 minus lambda, 0, 0, and 1, 0 minus lambda, I can say minus lambda, and 1 and next 0, 1 minus lambda. This determinant must be equal to what? 0. Now, I told you the technique. First of all, what we need to do? Lambda cube. Anna, forget about here. Next, lambda minus lambda square into sum of the principal diagonal elements. 1 plus lambda into, you have to write what? Determinant of here 1, cofactor of 1 and cofactor of 0 and cofactor of 0. And the cofactor of 0 is equal to what? Minus 1. Minus 1. Cofactor of 0, no matter whatever it is. 0. Cofactor of 0, no matter. Okay, first cofactor of 0 is equal to what? You can remove this column and you can remove this row and you can remove 1 0 into 0 0. Therefore, already here 0, no matter whatever these elements. Therefore, ultimately we will get the what? 0. Again, this element is also 0. What you will get? Ultimately, whatever the matrix, it will be the what? 0 only. That is, you can understand. Okay, right, beta. Next, what is the determinant of this matrix? Right, 1 0 0, right? 1 0 1 and 0 1 0. Okay, right. Along the principal diagonal, why? Because already it is identity, right? Minus 1 only. Therefore, already here minus plus minus again minus 1 is equal to what? 0. Therefore, what? Lambda cube minus lambda square minus lambda plus 1 is equal to 0. Lambda cube minus lambda square minus lambda plus 1 is equal to 0. This is what? This is what? Characteristic equation lambda. Okay, right. Now you tell me, according to the Cayley-Hamilton theorem, every square matrix satisfy its characteristic equation according to Cayley-Hamilton theorem. Okay, you can use this technique. Otherwise, nothing but in case if you are missing, I am giving the A, B, C, and let it be D, E, F, and A, B, C, D, F, G, H, I. Okay, how we are writing? Always lambda cube minus lambda square into trace. You can write A plus E plus F, and after that lambda into what? Cofactor A times of what? EI minus FH. A minus FH plus again cofactor of E. You can write plus again cofactor of I. You can write, and at last minus plus minus determinant of this matrix. Let it be this matrix A. Determinant of A is equal to 0. In this way, you can able to find the characteristic equation. Otherwise, if people can do what? They can expand. That is also fine for them. Why? Because that is also fine for me. Why? Because of 1 minus lambda. Here what it will come? Lambda square minus 1 is equal to 0. Ultimately, if you are multiplying, for this question, this is also easy. Why? Because of lambda square minus 1 minus lambda cube plus lambda is equal to 0. That is equal to what? Minus lambda cube plus lambda square plus lambda minus 1 is equal to 0. You can remove the minus, then lambda cube minus lambda square minus lambda plus 1 is equal to 0. Either way, you will get the same answer. Okay, lambda cube minus lambda square minus lambda plus 1. Are you understanding? Right. Now, according to the Cayley-Hamilton theorem, Cayley-Hamilton theorem, every square matrix satisfies its characteristic equation. This is the definition of the Cayley-Hamilton theorem. Okay. Therefore, what is that characteristic equation? A cube, nothing but a cube minus a square minus a plus here I must be equal to what? Null matrix. Now, they're asking what? Verify the Cayley-Hamilton theorem of the matrix A, right? Now, we have to show LHS is equal to RHS. Okay, for that, how to verification started? You can multiply the matrix just like a given matrix A square. You can able to find. Why? Because each and every time you have to find. And first A square, A into A. Whatever the matrix A, 1 0 0 0 1 0. Next, sorry. 1 0 1 0 1 1 0 1 and 0 1 0 into again 1 0 0 1 0 1 and 0 1 0. This is equal to what? You can multiply row and column. First element 1 into 1 plus 0 into 1 0 plus 0 into 0. Therefore 1. Okay, right. You know that matrix multiplication. I am copying. And 1 0 0. Right, 1 1 0. You can multiply just 1 0 1. And you can multiply. You know that how to multiply. Next a cube. A square into a square already 1 0 0 1 1 0 and 1 0 1. Again a 1 0 0 and 1 0 1 and 0 1 0. Again this row and this column. Again first element is what? 1 only. Okay, again I am copying a cube on my notes and right. You can multiply. It will take 1 more minute for you. Otherwise, you can use the calculator also. Don't worry. If you are feeding the calculator A, that automatically will get the A square. Why? Because in the maths optional, we can use the calculators, right? And non-programmable calculators are allowed in the inside of. Not only for maths option, any optional you can use the calculator. But what is the point for other optionals? If it is a literature, what is the advantage of to use the calculator? You tell me. Is there any useful? No advantage, right? But for maths optional, commerce optional, physics optional, there definitely there will be some advantage to use that. Especially maths optional is more advantage. Okay, right. 1 0 0 and 2 0 1 and 1 1 0. This is the AQ. Now take the LHS. LHS, what is coming? You can verify. LHS is called what? A cube minus a square minus a plus I. Already a cube 1 0 0 2 0 1 1 1 0 minus a square. Whatever the a square, this is the matrix, right? 1 0 0 and 1 1 1 0 and 1 0 1. Next again minus a. Whatever the minus a, 1 0 0 1 0 1 again 0 1 0 plus a unit matrix of thread 1 0 0 0 1 0 0 0 1. Okay, right. This is equal to dhyan se 1 minus 1 plus 1. Therefore, first element is 0. Second element is 0 minus 0, all zeros 0. Here is also all zeros 0. Here 2 minus 1 1 minus 1 0 0. Next, this is the minus 1 minus 0 plus 1 0. Everything is 0. That's it. That is equal to O. That is equal to what? RHS. Hence, Cayley-Hamilton theorem is verified. Hence, Cayley-Hamilton theorem is verified. Right? That's it. This is the first part. They're awarding for this and 10 marks. Therefore, that is the question. Next, what they're asking to show that in this question, show that a power n is equal to something. They are asking to show that. What is the second part? A power n is equal to a power n minus 2, a power n minus 2 plus a square minus I for n greater than or equal to 3. For n greater than or equal to 3. Okay, right. Where I is the identity matrix of order 3. Hence, find a power 40. Hence, find a power 40 also they are asking to show that. Okay, right. Now, how to verify? I am verifying this, this part, this relation, this equation by principle of mathematical induction. What relation I am using? PMI, principle of mathematical induction. What is the PMI? You know that whenever if you want to show that PN statement, whatever the statement is true, then always you have to show that what P1 should be true, must be true. You have to show that. This is, and you can take the let pk or pm, whatever it may be, depends upon the pm statement is true. You can take this one, and you have to prove that what pk plus 1 or pm plus 1 statement, anything can be, is true. You have to prove. Then you can able to generalize. What is that? For all k belongs to natural, k or m, whatever it may be, better depends upon what you have taken. Either for all k or m belongs to natural number. PM statement is also what? True. For all natural number, it is a true. Okay, here starting point is what? N is equal to 3. N greater than or equal to 3. First, what is the P1 statement? A3, you have to show the true. Are you understanding? Okay, right. For N is equal to 3, you can take. For N is equal to 3, this is my P1 statement. Don't think P1 means N is equal to 1. Why? This relation is starting from where? N greater than or equal to 3. Therefore, first statement is what? P1 means don't put the N is equal to 1. Don't think on that lines. P1 is not a N is equal to 1. P1 means first statement and kth statement and k plus 1 statement. Therefore, all statements are true. That is the logic. Okay. But in general, P1 means N is equal to 1 only. But in this equation, N is starting from where? Greater than or equal to 3. Therefore, N is equal to P1 statement, nothing but what? N is equal to 3. Okay, you can. Okay, right. For N is equal to 3. What about the LHS? A3, AQ. What about the RHS? RHS is how much? A3 minus 1. A plus A square minus I. Okay, RHS. Now you tell me that is equal to what? Already we have shown that Cayley-Hamilton theorem. What is this relation? You tell me. A cube minus A square minus A plus I is equal to null matrix. Therefore, what about the A cube? A square plus A minus I. Therefore, that is only. This is equal to A cube. Therefore, LH is equal to RHS. LHS is equal to what? RHS. Therefore, P1 statement is true. I have shown. Let PK statement is true. Let P of K statement, P of K or P of M, anything. Let P of K statement, PK statement is true or PK is true. If you want, no need to write statement, PK is true. Okay, right. Then A power K is equal to what? A power K minus 2 plus A square minus I, unit matrix. Now we have to show that what? Now we have to show that which statement true? Pk plus 1 must be true. Therefore, you can take the LHS. What is the Pk plus 1 statement? You tell me. Pk plus 1 statement. A power K plus 1 must be equal to A power K minus 1 plus A square minus I. K as K plus 1 you can put. K plus 1 minus 2. K minus 1. Okay. Right. This is equal to what I can say. And I take the LHS. LHS is equal to A power K plus 1. Sorry. A power K plus 1. That is equal to what? A power K into A. That is equal to what about A power K? PK statement. A power K minus 2 plus A square minus I into A. Therefore, what about here? A4k minus 1 plus a cube minus a, that is equal to a4k minus 1, a4k minus 1. What about the a cube? A cube value is equal to what? A square plus a minus I. A square plus a minus I. A square, a4k minus 1, right? A cube minus a, right? A cube minus this is a. Therefore, you can cancel the a minus a. You can cancel. This is what? A4k minus 1 plus a square minus 1. This is equal to RHS of the pk plus 1. Where is this? This is equal to what? RHS of pk plus 1. Therefore, pk plus 1 statement is what? True. Therefore, for all n greater than or equal to 3, n greater than Pn statement is also true. Therefore, a power n is equal to what? Therefore, a power n is equal to, you can write the statement a power kn minus 2 plus a square minus I for all n greater than or equal to 3. Hence, true. Okay. Now, they are asking the a power 40. Okay. They are asking the a power 40. And you can use the two methods. One is lengthy method, one is the shorter method. Anything whichever suits to you, you can use it. Okay. Suppose you tell me, you can put the, this is the relation, right? And you can put the n is equal to 40. Then what it will come? A power 40 is equal to a power 38 plus a square minus I. Again, a power 38 is how much? You tell me. A power 38. You can use n is equal to 38. Then that is equal to what? A power 36 plus a square minus I. Again, a square 2a square minus 2i. Are you understanding? Therefore, a power 36 is equal to a power 38 is equal to n is equal to 38. You can substitute a power 36 plus a square and this a square plus 2a square minus what? Minus I 2i. Okay, right. Again, a power 36 is equal to what? A power 34 plus again 3a square minus 3a. Continuing like this in this fashion, you will get the what? At the last, you will get the what? How many a square? You will get a square, nothing but 20 a square you will get. Why? Because half of that, right? Was every time you are reducing the 2. Therefore, 20 a square minus 19 I you will get. Why? Because every time you are reducing the 2, you are adding here one more. Why? Because every time you are adding what? A square minus I you are adding. Therefore, 20 steps. Okay, you will get the what? 20 a square. If you want, you can use the previous step also. If you want, you do one thing. Sir, a square and plus what? 19 a square minus 99. If I am proceeding like this, and 20 times I have to do. If I am doing the 20 times, if I am doing the one time, what I am getting? 2, right? You can reduce the 2. A for 38. This is equal to 1. Next 36. How many? 40 divided by 2, 20. Therefore, a square is equal to what? 19 a square minus 19. Ultimately, we are getting the what? 20 a square minus 99. But this method is not appreciable for me also. I won't encourage this method. I am giving the one more method, see, which you can able to follow. Why? Because you can, suppose if you am asking what is a for 2024 or what is a power 2023, then how to do? This is the question mark. Maybe few people cannot able to understand this logic. Then I am giving the one more simple method, see, which is not available in anywhere. I am giving the open challenge. Okay, right. Do one thing. Yeah, a power n is equal to what? A power n minus 2 plus a square minus I, or n is equal to 3 if you want, you can put. And you know that, what about the a cube? What about the a cube? A cube is equal to what? A square, nothing but a square plus a plus a square or a square plus a minus I. Okay. Now n is equal to 4 you can put. I tell you, see. You can put the n is equal to 4. Then a power 4 is equal to what? A power 4. A square plus a square 2a square minus I. Right? What about the a power 8? A power 8. N is equal to. You have to put the what? Otherwise, you can squaring on both sides. If you want, you can squaring on both sides. A power 8 is equal to what? 4a power 4. Okay? 4 plus I square, I only, minus 4a square. 4a square. A power 4, how much? 2a square. 4 into 2a square minus I plus I minus 4a square. This is equal to 4 2 is 8 minus 4. 4a square minus 4i plus I plus minus 3i. 4a square minus 3. Therefore, what you got? A power 8 is equal to a power 8. A power 8 is equal to how much? 4a square minus 3i I got. Okay, right. And one more time you can square, I tell you. A power 16 is equal to what? 16a power 4 plus 9i minus 4 is a 24a square. This is equal to how much? 16 into what about the a power 4? 2a square minus I. 2a square minus I plus 9i minus 24a square. This is equal to what? 4 2 16 2 32 minus 24 8a square minus 16 plus 9 7 minus 7. Again you can go for square a power 32. Now you can able to multiply. Now you again a power 16 is how much? 8a square minus 7i. Again you can square, you will get the what? A power 32, and after that you can multiply by the a power 40 is equal to what? A power 32 into what? A power 8. You can multiply, you will reach the answer. That is the one thing. And second, see, here is also one more method. You can observe one pattern here. One pattern you can observe. A power 4 is equal to what? A power 4 is equal to what? 2a square minus I. 2a square minus I. A power 8 is equal to what? 4a square minus 3a. A power 16 is equal to what? 8a square minus 7i. Now, 3 times you can observe what it will come a power 32 without any simplification. You can say what it will come a power 32, or what about it will come a power 40? Nothing but 16. See, 8 by 2, 4 by 2, and after that n minus 1. Are you understanding? A power n. What is the formula here? A power n is equal to what? N by 2 into a square minus n by 2 minus 1 into I. This is only you will get. A power 16, 16 by 2, 8, minus 8 minus 1, 7. For a power 8, 4 by 2, 4, minus 4 minus 1 is equal to what? 3. Therefore, a power 40 directly is how much? N by 2, nothing but 20 a square, 20 minus 1, 19, 99. That's it. Now, maybe you can argue, sir, a power 2024, how to get? That is very simple. N by 2, nothing but 1 0 1 0 1 2 a square minus 1 0 1 1 I. Sir, what about a power 2023? How to get? How to get? Sir, the 2023 by 2, it is a not integer. Don't worry. Now you can able to find what? A power 2022 you can able to find. Into you can multiply a. Simple. Are you understanding? E power 22 you can able to derive the formula, right? Are you understanding? Then you can multiply with the, that's it, over. Anyway, come to that original question. Therefore, 20 into, you know that previously we have find the a square. I know I am using that matrix only. Therefore, a square is equal to what, beta? I know 20 into their matrix 1 0 0. We got 0 1 0 1 1 0 and 1 0 1 minus 19 into what? 1 0 0 0 1 0 0 0 1 unit matrix. Ultimately, final answer is how much better? Final answer here, this is equal to 20 0 0 20 20 0 20 0 20 minus 19, 0, 0, 0, 19, 0, 0, 0, 19. And only you can do the by operations on along the principal diagonal. Rest of the elements you can keep the same on this matrix. Therefore, 20 minus 19, 1. Here is also 1. Here is also 1. Rest of as it is 0, 0. Next 20. And rest of elements as it is 20, 0. That's it. 1, 0, 0, 20, 1, 0, 20, 0, 1. This is the A power 41. Okay, right. Always first element is the 1 only. Therefore, A power 80, what it will come? A power 80 if you need. 1, 0, 0, 40, 1, 0, 40, 0, 1. That's it. Now, this is the question. And a Cayley Hamilton theorem. Doable question only. Okay, na? Same question maybe you can be able to find, but you can able to do. It is not a big deal. And what is the one more linear algebra question? Yes, here we have. And find the rank of the matrix by reducing the row reduced echelon form. Okay, they're asking the rank of the matrix. That's it only. How many marks? 15 marks. Wow. Okay, na? This is the 10 marker question. They have increased the 5 marks. Okay. Okay, I am writing. And 1, 2, 0, 1, 2, sorry, 1, 2, minus 1, 0, 0, and minus 1, 3, 0, minus 4. Next, 2, 1, 3, minus 2. Next, triple 1, minus 1. They are asking the rank of the matrix. Why? Because this is the square matrix. You can able to find the determinant of 4 by 4 matrix. If it is not equal to 0, then again go for 3 by 3. Lot of options will come. Therefore, the only option, even if they are not mentioning also, you have to use the echelon form. And even they have clearly mentioned how we are converting the echelon form. Row reduced matrix only. You have to use the only row operations. We should not use the column operations in echelon form. Okay, clearly they are mentioning find the rank of the matrix by reducing to the row reduced echelon form. If they're not mentioning find the rank, you have to use this method only, row reduced echelon form. Why? Because of determinant, if it is equal to 0, then problem. If it determinant is not equal to 0, sir, the rank is equal to 4. You can able to argue, sir, the rank is equal to 4. If it is a 0, then can't we say that? Can we say that rank is equal to 3? We don't know. We have to find rank of the matrix. You can understand, right? Therefore, echelon form is the best method. Normal form, it will take the double time. Normal form or standard form or canonical form, it will take the double time. Okay, echelon form will be the, for finding the rank, echelon form is the best method. Therefore, only row operations you can able to convert it into echelon form. Always focus on the pivot elements. Already this element is the 1, therefore you can use the operations. What? R2 plus R1. You can make the zeros here. Why? Because every non-zero element below will be the what? A zero element. Every non-zero element below has to be the 0. That is important. Okay, that is R2 plus R1 and R3 minus 2 times of R1 and R4 minus R1 you can do. Then this matrix equal to what? 1, 2, row 1 will not change. And this is 0. You can add simply 5 minus 1 minus 4. Next, you can subtract, multiply 2, subtract. 2 1 are 2, 0. 2 2 are 4, minus 3. 2 1 minus 2, 5. This is equal to what? Minus 2. Again, subtract 0, 1, 2, minus 1. Okay. Maybe on the hurry, I can able to do the mistakes. Again, I am verifying 1, 2, minus 1, 0. Okay, 1, 2, minus 1, 0. 0, 5, minus 1, minus 4. Yes, right. 0, minus 3, 5, minus 2. And 0, minus 1, 2, minus 1. I have done the mistake here. What is the operation? R4 minus R2, right? Yes, it is a minus 1. Okay, right. Next, already here 5 is there. And I can change the rows, R4 to R3. Otherwise, you have to do the lengthy operation. Don't make divided by row 2, into 1 by 5. It will be the little bit complicated. And don't do that. Already it is 1 is there, right, in this below. Therefore, you can interchange the rows. That would be the better operation. Therefore, I am doing that operation only. Okay, what I am interchanging? R2, R4. Two rows I can interchange. Okay, therefore, first row as it is 1, 2, minus 1, 0, 0, minus 1, and 2, minus 1. Right, and next after that, what? Third row as it is 0, minus 3, 5, minus 2. Row 2, I have to replace on row 5. 0, 5, minus 1, minus 4. And some people, they can use the one more step. They can make the 1 here, and you can multiply minus 1. Otherwise, not required. Okay, I don't think so. Why? Because echelon form not necessary. Principal diagonal elements must be the 1, and that is not required. Why? Because of entire mathematicians, they are not agreeing. The principal diagonal element must be 1 or unity, even non-zero element. Even if the principal diagonal element 0 also doesn't matter. Okay, right. And the number of zeros must be, it will increase. Right? Right. Next, this operation is equal to what? You tell me, here I have to make the 0. Therefore, R3 minus 3 times of what? R2, and R4 minus 5 times of R2. Plus. Why? Because already minus, right? Here, because of minus, this is 0. Therefore, first row, 2 rows as it is. 1, 2, minus 1, 0. Next, 0, minus 1, 2, minus 1. Next, you can multiply by 3 and subtract 0. And you can multiply 3, subtract 0. And 3 2s are 6. 5 minus 6 is minus 1. Next, minus 3 plus 2, 1. Next, here you can multiply by 5, subtract 0. You can add, and 0. 5 2s are 10. 10 minus 1. 10 minus 1, 9. Next, 5 minus 5. You can add minus 9. And you can do one thing. You can remove the R4 into 1 by 9 or minus 1 by 9. Anything you can do. R4. Then above matrix is what? 1, 2, minus 1, 0. 0, minus 1, 2, minus 1. 0, 0, minus 1, 1. And 0, 0, 1, minus 1. And you can do the last. What is the operation? You can do the R4 plus R3 you can do. And why? Because then automatically it will be the 0. Okay, this is the pivot element, right? Right. Therefore, 1, 2, minus 1, 0. And 0, minus 1, 2, minus 1. 0, 0, minus 1, 1. And 0, 0, 0, 0. Last two rows are equal actually, in fact. Why? Because 1 is a scalar multiple of other. Okay. Therefore, already this is echelon form. Therefore, this is the non-zero element, all these are 0. This is the non-zero element, all these are 0. This is the non-zero element, in below is 0. The number of zeros are what? Increasing. Here 1 0, here 2 zeros, here 3 0. Therefore, clearly, which is in the echelon form. Therefore, rank of the matrix are what? Number of non-zero rows in the echelon form. Therefore, rank of the matrix. Rank of the matrix is equal to number of non-zero rows. Nothing but this is the 0 row. These 3 are non-zero rows. Number of non-zero rows in an echelon form. That is equal to what? 3. Therefore, rank of A given matrix is equal to 3. That's it. This is a 10 marker question only, but they are awarded the, maybe you will get the different matrix. Okay, ultimately everyone will reach the same rank. Therefore, all the linear algebra, these kind of questions, okay, na, you can found by any of the materials. Doesn't matter. I won't think linear algebra. These don't be the committed with the false information. These questions from our study material. I don't want to encourage for any of you. Okay, these are the standard question only. Most easiest questions only. Everyone has to know. Therefore, these kind of questions you will appear. Maybe not the same question, but similar kind of concepts. Each and every textbook, standard textbook, non-standard books, even every institute, they have to claim. It is not a big deal. Okay, therefore I won't encourage you. Okay, people are falsely committing this question from our study material, and this question from our study material. Don't fall fall on the trap committed by them. Okay, they can cheat you, showing the no need to show this. You can pick up. I am giving the open challenge for you. You can pick up any linear algebra matrices book. You can able to find such kind of questions. any 4 by 4, 5 by 4, 6 by 6 matrices you can find, you can able to determine the rank. Okay, similar kind of questions, same kind of questions, it will be there. Therefore, linear algebra is the doable and a doable one. Okay, therefore you cannot able to leave even a single question on the linear algebra anywhere. But how to select the questions? And Sarji, if I'm doing the way of I'm teaching, explaining linear algebra, you won't solve by on that way. Why? Because don't pick up the linear algebra questions. It is wastage of time. What kind of questions you have to select inside the examination? I will give the strategy end of the video, or maybe I can give that video of the description of the description link. I can mention the video link on the description. You can simply click on that. You will see that what is the best questions you can able to track, you can able to select. See, question number 1 and 5 are compulsory. Okay, question number, therefore you have to select 3 more questions from the section A and section B. At least you have to pick up the one question from 2, 3, 4 and at least one more question from 6, 7, 8 questions. And fifth question is the choice for you. And how to select questions from the 2, 3, 4, I will give the tricks. And how to select the question from at least one question from question number 6 and 7 and 8, how to select. Okay, that will help you. Why? Because ultimately your goal is what? You have to solve the 5 questions.